All right, so we're going to do functional groups part 2, so to speak. Or continued, I guess is better, but that's what we'll call it. Okay, so now what we're going to do is we're going to look at some of the variable things that can happen with these functional groups. Okay. We're going to look at something like let's look at the carbonyl group first. It's the one that I think was confusing some people yesterday. So the carbonyl group, which typically is got a double bond O and then an H attached to it. Well, this is the reactive end of a molecule. And so what can happen is the way it reacts, this end, the way it reacts typically is this hydrogen gets popped off, pulled away by water likely, right? The water dance. And something else, some other thing can go in here and join up. So when you're done, you have something that looks like this with a double bond O sort of stuck in the middle, and then another thing. So these are R1 and R2, two different chunks of molecule. And you'll notice, if you look in the textbook, you'll see that when this happens, this is page 26. You should keep this open and follow along, I guess, if you want. You can see that happening here between two methane molecules. And this is called a ketone. So when it happens like this in the middle, it's called a ketone. And so it's sort of a linkage or a bond that has formed with an alkyl, or sorry, a carbonyl and something else. Okay? So this can be on the end or it can be in the middle. So when it's in the middle, it's called a ketone. So here's an example of a ketone. You have, let's say, C, H, 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 C, H, and this could be anything. It could be something like that. And then what you end up with is a C in the middle, right here, with a double bond O on it. And then you carry on with another molecule, or another chunk of stuff, something like this. And this might, maybe this has 3. It doesn't have to be symmetrical, right? So this is the sort of R1, whatever chunk that is. This is the R2, whatever chunk of stuff that is. But in the middle, we can see this, which is the same as that. And so that's what happens when a carbonyl sort of pops off its hydrogen and joins up with something else. And so this is called a ketone when this happens, ketone. So on the worksheet, you wouldn't have known this word, but there were a couple like that, right? So that's ketone, okay? Now, when it happens on the end, of the molecule, so you have R, and then the C, and the double bond O, and the H on the end, with the H still attached, that has another name. That's called an aldehyde. So you might have heard of formaldehyde, maybe. That's a chemical we used to use to preserve things, formaldehyde. They used to use, I don't know if they still do, but they used to use it for embalming dead bodies. They used it for preserving specimens and things. But I think it's carcinogenic mildly, so we try to avoid it, I think, nowadays. So the name of the aldehyde would depend on what the R is. So you can have ethaldehyde or methaldehyde or propaldehyde, or any of those molecules we talked about that have the ending on them, that would be their name. So if you took propane and you put a carbonyl on the end, you now have propaldehyde, which is a weird chemical that we don't hear of very often. But aldehydes are quite important in biology. Okay? And so that one would look like this. Let's say the R was C. Here, let's do ethaldehyde. So 2 C's is ethane, right? Remember we did that when we did the prefixes? 2 C's is ethane. This is also sometimes called an ethyl group. So that's another organic chemistry when you get into that. And then here, we would have the C with the double bond O and the H attached on the end, not stuck in the middle or joining with anything. So therefore, it's called an aldehyde. So that's the distinction between those two. Now that you know about carbonyls, you can spot them in the middle of a molecule where they've joined, making a ketone, or at the end of a molecule where they are sort of not joined. Yes, ma'am. Yeah, so R in this case happens to be this green stuff, but there could be anything over here, right? That's the whole point. The key thing is not to worry about what's attached. The key thing is to be able to spot these groups. That's what we're trying to do. Okay, so I'm going to pause this stuff. Okay, let's draw a line under here, and let's look at some other options. If we have a typical molecule, let's draw a couple carbons in here. This. And let's put an OH on the end. Well, as we said, that H can be popped off, and something else can be joined onto it. And so what we could get is another piece of molecule. Let's say it's this. Right? And this H could pop off, and this molecule could join to that one, which would result in this. And then we'd have this O, and then we'd have the other piece, like this. So it looks like it used to be a hydroxyl group whose H popped off and something else was able to join. And so this, when we have this linkage here, or this group, this is called an ether, or an ether group. And it's a very common way of joining little molecules together to make bigger ones, and we'll see it all over the place. Another thing that can happen is if I take, I'll just draw one carbon this time. Well, actually, no, I'm going to draw two. And I take this carbon, and this carbon happens to have a carboxylic acid group, C carboxyl group, right on the end, and something else comes along. Okay, it's quite possible for these H's to pop off. And by pop off, what do we mean? What pops them off? The water could be a thing that pops them off. So if these molecules were in water, these H's could be sort of popped away, and then what we get is a combination. Can I go up? Yeah. Over there? Oh, you have a slow writer. Okay. Stop, stop, stop. Stop. I'm going to try this. There you go. You still writing down the ether? Can I go like that? I'm good, okay. So this would be the original piece of the molecule. And so we have to be able to spot this. Now this other C has sort of linked itself on. So what we have here, right, is what we call the ester group, or ester linkage. Ether and ester. So carbonyl groups, hydroxyl groups can link together to form ethers. Carbonyl groups can link together to form ketones. And carboxyl groups can link together to form esters. Got it? So now we have these linking ideas, as opposed to just identifying the hydroxyl groups. We can also see them as linkages that combine molecules together. Okay? All right. I'll let you finish that. I'm going to stop the recording though, because that's the end of this video.